Sports are a big deal. About 35 million youth play some type of sport, and many others are engaged in physical activities. These athletes train hard, often pushing themselves to their physical and mental limits in hopes of reaching the top of their sport. A sometimes overlooked factor in their performance is the gear they wear. Let's look closer at how clothing can help the athlete regulate his or her body temperature. Thermoregulation of clothing helps your body temperature stay in a safe temperature range. This is especially important for athletes who are often too hot or too cold and may have to deal with extreme weather conditions. Today's sports enthusiasts are lucky that modern activewear includes high-performance fabrics, innovative garment design, and smart clothing, or clothes that respond to some type of stimuli, such as temperature. By using clothing to maintain the proper body temperature, athletes can minimize heat-related injuries while performing at a high level. To understand how clothing is engineered for thermoregulation, let's meet the inventor of the thermal mannequin, Dr. Jin Tu Fan.
Thermal comfort means our human body's temperature should be within a very narrow limit. And also, it should not require us to perspire sensibly, which means sweating. We have to have clothing to help us to be able to live in this wide range of thermal environments. Talk about exploration to the space or to the North Pole, South Pole, to all these extreme environments. Thermal comfort of clothing is important to our performance in a moderate environment. But it's about life and death in the extreme environment. Thermoregulation differs from thermal comfort. Thermoregulation means that the material or the garment is able to change, to regulate, to respond to the changes of the human body and the environment. For instance, you heard probably materials when the temperature is low, it can close the pore, right? So it will be more impermeable and to retain the heat. You heard about phase-changing materials. So when a person wearing phase-changing material going from a hot to a very cold environment, the phase-changing material will release heat to help the human body to better adjust to the environment. I look at how to objectively evaluate comfort, and particularly thermal comfort. With that, I developed a number of instruments, including the thermal mannequin.
This is the thermal mannequin known as Walter. Here we have a water tank that will act as a sweat for Walter. As Walter's temperature rises, he sweats more. Water escapes through a layer of permeable fabric that acts as a skin. Different garment and materials will cause Walter to sweat more or less. We measure the amount of water that's lost. We can use this measurement, for example, to determine how well this clothes can keep you cool on a hot day.
The critical issue in developing this instrument is to make the instrument realistically representing the actual use condition of the clothing. At the same time, provide a very accurate and reliable measurement. My future plan is, on one hand, we want to further improve the instrumentation, and particularly water, to be more close to the human body in terms of motion, in terms of the sweating distribution. On the other hand, we want to develop smart materials which have a thermoregulation function, and that helps the human body to regulate its temperature. You want the sportsman does not reach its critical temperature, body temperature, too quickly. right? Because when he doing certain sports or certain activity, the metabolism increases greatly, and heat generates a huge amount of heat generated. So the body temperature tends to rise. Now, if the body temperature goes too high, then the sportsman is in danger, and his performance will deteriorate, right? So you want sportswear to reduce the rate of the body temperature's increase.
Regulating body temperature may require the use of insulation materials. Let's compare some of the materials used in footwear, such as wool felt, aerogel, and polyurethane foam. Place the shoe soles on a block of ice and stand on them for 10 seconds. Based on the sensation in your feet, you can rate the soles from coldest to warmest. Because some soles may be very close in the degree of insulation, we can use a temperature gun to see the small differences. One important lesson is that the thickest sole is not always the warmest. Thin materials that are engineered for insulation may be more effective.
Now, why is it so more important today? I think because we want to have a better performance in everything we do, right? And thermal comfort is so much related to our human well-being.